All right. So both of these worksheets have to do with angles in standard position. So here is the Cartesian plane. Remember that 0 degrees is the positive x-axis. We talked last year about turning a dial. And for trig purposes, the dial is length 1, which creates the unit circle. We'll talk about that tomorrow. So we always turn it counterclockwise is how you create positive angles. So this would be 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So one of the worksheets has you draw angles. Where is 196 degrees going to land? What quadrant? Remember, this is 1, this is 2, this is 3, and this is 4. So 196 would be in quadrant 3. Okay? Now, another one of the worksheets asks for the reference angles. The reference angles are always the smallest angle to get you back to the x-axis. So in quadrant 1, that would be the reference angle. Any angle in quadrant 2, this would be the reference angle, that would be the reference angle in 3, and that would be the reference angle in 4. So if this line is 196, what is the reference angle? 16, because you need 16 degrees to get back to 180. Now, reference angles are always positive. They're always positive. Okay? So if I asked, what is the reference angle for 425 degrees, how would we figure that out? So we'd subtract 360, and we get 65 degrees, and that actually is the reference angle. Okay? What about negative 781 degrees? So we add 360, and we get, what is negative 781 plus 360? Negative 421. And then we would add 360 again, negative 61. We could add 360 again and get positive 299. What quadrant does 299 lie in? 4, right here, and the reference angle is going to be 61. So this angle would be 61 degrees. Okay. What about radians? How many radians are there in a circle? More than 1. More than 4. Well, yeah, more than 4. What? Uh-oh, you guys don't remember this at all. This might have come back to bite you on the ACT. So radians are based on pi. Two pi. So a full circle is 2 pi, which means that half a circle is pi, which means that a quarter circle is pi over 2. 3/4 of a circle would be 3 pi over 2. And it's also good to use the decimals. So this is 0.5 pi, 1 pi, and 1.5 pi. Okay, so you just kind of have to remember that. So what is the reference angle for 7 pi over 6? Well, it's not 7/2, it's 7/6. No, not around once. Turn 7/6 into a decimal. 1.6 1.1816 pi. Where does 1.16 pi land? In third quadrant. So that's half a pi, a full pi, and an extra sixth. Right? So if that is 7 pi over 6, how much do I need to backtrack to get to 1? 1/6. Because really 1 is just 6 over 6. So we're trying to find the difference between 7 over 6 and 6 over 6, which is just 1 over 6. Okay, what if I had 18 pi over 11? So type it in, 18 divide 11, and you get 1.6. Yes. Yes. We'll talk about it tomorrow. No. Our pi day will be Thursday. We can't all have it on the same day, so I picked Thursday. So 18 over 11, what is that as a decimal? So this is 1.6 pi. Where does 1.6 pi land? Quadrant 4. So this is the reference angle. So, hey, we'll talk about pi day another time. How much more do I need to reach 2? Well, what would 2 pi be in 11ths? 22 over 11 pi. So how many 11ths do I need to turn this into 22? To turn 18 into 22, you need 4 11ths. So the reference angle is 4 pi over 11. Okay? So if I gave you something really large, like 25 pi over, let's do 4, 4 is not going to work, 7. What is that as a decimal? 3.5? Oh well. No, 3.5 what? Why did I need 3.57? Well, 0.5, 1, 2, 2.5, 3, 3.57. So we're in quadrant 4. Okay? And this is 3.57. What am I trying to reach? 4. So 7 times 4 is 28. How many more sevenths do I need to reach 28 sevenths? 3 sevenths. So the reference angle would be 3 sevenths. So we landed here, 3.57, and we're trying to get to 4. So the fraction we have is 25 over 7. And we're trying to reach 4 times 7. We're trying to reach 28 over 7. In order for that to work, we need an additional 3 sevenths. So you're just trying to get back to the x-axis. If you're in quadrant 2, you figure out how much more you need to reach 1. If you're in quadrant 3, how much do you have to backtrack to reach 1? If you're in quadrant 4, how much do you need to reach 2? Or 4, or 6, or 8, depending on how many times you went around. Okay? Reference angle, we covered that. Okay, you want to do a negative one? Okay. So, negative 4 sevenths pi. What's the reference angle? Well, 4 over 7 is negative 0.57. What quadrant is that going to be in? not 4, because this is negative 0.5, so it's going to be in quadrant 3. What am I trying to reach? You're trying to reach negative 1. You're trying to figure out how much more do I need to get back to the x-axis. Well, if I've already done 4/7, how many more sevenths do I need to turn that into a 1? 3/7. So if this is 4/7, then this distance is 3/7, for a total of 7/7. Pi over 2. Negative, yeah. With the negatives, the two y-axis values switch. Okay, so do you understand why the reference angle is where it is? Do you understand why this line is where it is? So this rotation is 4/7. And this is 1 pi. Actually, in this case, it's negative 1 pi. How much more rotation do I need to turn 4/7 into 1? 1 is 7/7. So if I already have 4/7, I need 3/7 more to reach the x-axis. Yeah. But if it was negative 8 pi/7, then that's going to land me in quadrant 2. How much do I need to backtrack to get back to the x-axis? I went too far. I need to go back 1/7. Reference angles are always positive. Yeah, so the answer in this case would be 1/7 pi. Okay? So, coterminal angles just means angles that land in the same position. So if I gave you the angle 160 and the angle 10,020, how can I tell if they land in the same place? Just keep adding 360 to it. And if I skip over the top of 1020, that means they don't. What if they were fractions? What if I had 8/5 pi and 118 pi/5? We add 2, but we'd have to keep turning it into a fraction, right? So you could find the decimals. This is going to be 1 point, let's see, 3/8 would be 0.6. What is this one as a decimal? 23.6. Do they land in the same place? Well, how? You say yes, why? What would I add to 1.6? Well, what's a full circle in radians? 2 pi. So if I add 2 to this over and over, am I going to reach 23.6? Yeah. So if the decimals match and they're both odd, you automatically know that they're in the same place. So what if I add 0.4 and 3.4? Well, if I add 2, then I get 2.4, and if I add 2 again, I get 4.4. So no. So in radians, just convert them to decimal and just keep adding 2, or if you're smart, these are both odd, so it will work. If I had 4.6 and 100.6, yes, because they're both even. Okay. Finding coterminal angles. So it gives you an angle, and it says find another angle that lands in the same place. How would you do that? Add 360 or subtract 360, depending on where it is. And it tells you the answer has to be between a certain range. Okay, on the other worksheet, convert from degrees to radians. Oh, actually, I think I have one right here. That was me. Don't worry about it. Those are all entered, so. Who was it? No, he didn't get credit. Is he here? Sorry. Hang on to it for a second. Okay. Um, so, converting from degrees to radians. So we know that on the left side we have pi, which is equal to 180 degrees. So those are the numbers we're going to use as our conversion factor. So if I have 325 degrees, I'm going to times it either by pi over 180 or 180 over pi. How do I know which one to use? Well, I have degrees to start with, and I want to end with radians, so I want the degrees to cancel. So I'm going to use the one that has the degrees on bottom, pi over 180. That way, degrees cancels degrees, and I'm left with 325 pi over 180. And now all you have to do is simplify the fraction. So what is 325 over 180? What is it? 185? 125? Speak up. 25 over 18. 20, and then you have to put the pi on. So 25 pi over 18. So look at number 5. If we want to go from radians to degrees, we put 180 on top and pi on bottom. Pi cancels pi. What is 23 times 180 divided by 12? .345 degrees. And if there are negatives, it just stays negative. Okay? And then the rest of this worksheet is pretty simple. It just gives you an angle. Let's look at 16. That one's kind of tricky, actually. So, if we know that this angle, the reference angle, is 5 pi over 12, what is the positive angle that goes around 1, 2, and a little bit extra? Well, to go around twice would be 4 pi, right? And then we just need to add that to what? Not 5 pi over 12, but the difference between 5 pi over 12 and starting position. Right? It would be the, would you say opposite? It's the angle, the positive angle that creates the reference angle 5 pi over 12. So how far do I have to rotate so that my reference angle is 5 pi over 12? 7 pi over 12. So I'm going to add 7 pi over 12 to 4. So what is 4 plus 7/12? Well, you're just going to add 48 to this. So 55 pi over 12. Does everybody understand that? The 48, 4 times 12. So going around twice, 6, 12, 24, 48, plus 7 more. All right. You should have plenty of time to answer these. Let me stop the video.